Hello, let's continue our lesson on differentiation. And today we are going to look at the concept of the chain rule. Okay, we are going to look at when we apply the chain rule in differentiation of a function. Okay, so normally the chain rule is applied, let's say, when we have a function which is more than a term, okay, and then the exponent may be maybe a higher value. Okay, for instance, if I have, let's take it for instance 2x, y is equal to 2x plus 5 to the exponent of say 5. All right, if I'm supposed to differentiate this particular function here, okay, 2x plus 5 to the exponent of 5, you see that it will be very tedious to expand this using the binomial expansion. You get a lot of terms, about 6 terms, all right, before you do it one by one to differentiate. So let's take it for instance, if this is my function here, okay, and I want to use the chain rule to differentiate this. So what I'll do is that one, I'm going to differentiate the entire expression here. So I will let the binomial here, okay, whatever, if it is binomial or trinomial, whatever it is, you represent that one by what? By a variable. Okay, so maybe you say let u to be equal to 2x plus 5. Okay, if my u is 2x plus 5, then I can now say that my y will be equal to, because the whole of this u is what? 2x plus 5. So my y becomes what? The u exponent 5. You see that? Because I have represented the whole of this binomial here, expression here, by what? By u. So when it's happening like that, then my u becomes what? Y to be equal to u exponent what? 5. Then with that, what I'm going to do, if you want to apply the chain rule, what you do here is to represent the binomial by a term. Like, so I represent the binomial by a term u. So if my u is the binomial, then my y is equal to what? U exponent 5. Okay, yes. So then what you do is to differentiate. So you take this as one term, okay, then you differentiate this as a term. The whole 2x plus 5 exponent 5, this become one term. So what will happen? The 5 will come here and you subtract 1 from here. Okay, then after that you multiply by the differentiation of what? Whatever is in the bracket here, the binomial, if it's binomial or trinomial or whatever it is. So you differentiate this as what? As one term, okay, where its exponent is 5. After you are done with that, then you come and differentiate what is in the bracket, and then you multiply. And you see that is what is happening here. So we come by getting the chain rule. Okay, so that is what is happening here. I have taken 2x plus 5 as one term as what? As u. So my y will be equal to what? U exponent 5. Then what will happen? Like, I will differentiate this, then I also differentiate this. Then after that I'll multiply the two. So see what is going to happen. So when I differentiate this, it will be the u on the x. So I'm differentiating u with respect to x, and that will give me what? 2. This will give me 0. Then when I come and differentiate this, the y on du, I'm differentiating with respect to u. That will be what? 5u, and I'll subtract 1 from here, exponent 4. So this will give me 5u exponent what? Exponent 4. And this is also d. So this is du over dx, which is 2. dy over du, which is 5u exponent 4. So if I want to write my answer, then I write as dy on the x, okay, is equal to the differentiation of this, which is this one, 5u exponent 4, multiplied by what? Multiplied by the differentiation of what is in the bracket, which is what? Which is 2. All right. But what is my u? So I can write a dy, okay, on the x will be equal to what? Will be equal, what is my u? My u is what? 2x plus 5 exponent 4 multiplied by 2. Then my answer becomes 2 multiplied by 5 to give me 10 then 2x plus 5 all to the exponent of 4. All to the exponent of what? All to the exponent of 4. Okay, so I will now substitute the value of u there, which is 2x plus 5. Then my answer becomes, so the differentiation 2x plus 5 or exponent 5 becomes what? 10 into bracket 2x plus 5 or exponent what? 4. And this is so simple, alright? So maybe as I've done it like this, you may get a little bit confused. Don't be confused. We are still on the right path. As we continue, it will be very, very, if you have not understood it now, it will be very, very simple for you. Okay, so when you are differentiating a function, okay, which is more than 2 terms and the exponent is of a higher value, what you do is that take the whole function here, okay, it is to exponent of what? 5. So you bring your 5 here, then you subtract 1 from this, okay, which becomes 5 2x plus 5 exponent 4. So you have differentiated the whole of this. You have taken just this as a term and you have differentiated. So 5 will come here, multiply this particular binomial. You subtract 1 from this. After that, you multiply by the differentiating of what is in the bracket. So this will give me what? 2. Then 2 multiplied will give me 10. Then 2s plus 5 exponent 4. You see that? So this is so this, out of this we can get our chain rule formula, which is dy on dx to be equal to what? When we differentiated this, we multiply dy over du by du over what? Dx. So that if I cancel du by du, I'll get dy on dx. So this is the chain rule formula. So here y is expressed in terms of u and u is expressed in terms of what? In terms of x. Okay, you are differentiating a function by a function. Okay, so this is what we have. So this becomes our chain rule, and I think this is not anything difficult. This is so simple, and when we start solving questions, you understand. So take note of the dy over the s is equal to dy over du times du on the x. All right. So we are going to solve some questions right now. Okay. Okay. Let's look at these examples. Okay. I want us to solve as many as 1, 2, 3, 4, 5, 6 examples, so that you get the whole concept of the chain rule. It's not anything difficult. All right. Okay. Let's start from here. A. Y is equal to 2 minus 3x all to the exponent of 5. Okay, 2 minus 3x all to the exponent of 5. So if you understand the concept of the chain rule, then there is no need even writing your formula before you can work. Okay. However, let me use the formula for the first one. The next one we go, I will use how we understand it, and then I believe you will get it. So if you get it, because this is what more than one term, you can say that let u be equal to what? 2 minus 3x. Then if u is equal to 3 minus 3, 2 minus 3x, then what will happen? The whole of, we can rewrite the expression here as what? Y is equal to 2 minus 3 is now u exponent 5. So if you are using the chain rule, then your differentiation become what? Dy on the x equal to dy on what? Du times, then the u will come du on what? Dx. So that when we cancel, you get the dy on dx. So dy will start over du, then the u will come here over dx. So that, as I say, when we cancel this, we get dy over dx. Okay, so dy will start at the denominator, the x will end at the denominator here, and then the du will come at this diagonal side here. Okay, then if that is the case, this is so simple. It means that you are differentiating this and you are differentiating also, you are differentiating this and you are multiplying. That is the meaning of what? The chain rule. Okay, so here then I can say du, okay, on the x is equal to what? Negative 3. So this will give me 0, this will give negative 3. And then I can also say here that my dy on my du is what? I'm differentiating with respect to u is 5u exponent 4. So 5 will come here and I subtract 1 from here. So that I get my du on the x as -3, dy on the u as 5u exponent 4. Okay, so therefore my dy, okay, on the x will now be equal to what? Du dx, which is 5u. But what is u? You do substitution. 2 minus 3x exponent 4 times the u on the x, which is -3. Alright, so my answer now becomes -3 by 5, -15, 2 minus 3x all to the exponent of 4. So this is my differentiation of 2 minus 3x all exponent 5 is -15 into bracket 2 minus 3x all exponent 4. Okay. And what I want to say is that even without writing all this, let u be equal to this and that and that. This is so simple. We could have done this in a short while. So simple. What do you do, okay, so that you don't become confused by all that we have written there? One, differentiate the whole thing, okay? So my y is equal to 2 minus 3s all to the exponent of 5. So I will say my dy on the x. You are really straightforward. I'll differentiate the whole of this. So 5 will come and multiply what? 2 minus 3s. Then you reduce this one by 1, exponent 4. Then you multiply by the differentiating of the binomial. Okay? So this one will give me -3. So that I will get -3 times 5, -15. 2 minus 3s all to the exponent of 4. Is it not the same thing we have here? It's the same thing. Okay, rather than writing all these things, this is so simple to do. All right, I know as you move on, you understand it better. Let's move to the next question. Y is equal to 2s cubed plus 2s squared plus 1 exponent 5. Okay, all these are objective questions. So dy on the x will be equal to 5. Then 2s cubed plus 2s squared plus 1. Then I reduce this one by 1 to be 4. Multiply by, okay, multiply by, then I'll differentiate whatever is in the bracket here. So 2s cubed will give me what? 2, 3, 6. 6s squared. Then this one will be plus 4x. This one is 0. Okay. Can write this multiplication sign if you like. So what we do is what? Take this whole thing, you bring your 5 here, and you write whatever is here, reduce it minus 1, so become 4. Then multiply by the differentiating of what is this trinomial 1, 2, 3. So become 3x. 3 times 2 becomes 6. So 6. Then you subtract 1 from here, so 6s squared. Then 2 times 2 becomes 4. And I subtract 1 from here, so that will give me 4x. And then this one becomes what? The one becomes 0. Okay, so after that, I can say my dy on the x is equal to what? You can multiply the 5 by this, okay? Since this is already exponent 4, so I can take the 5 and multiply by this, okay? So I will have 5 multiplying 6s squared plus 4x into bracket 2s cubed plus 2s squared plus 1 exponent 4. Then finally, you can, if you like, can expand, okay? My dy on the s will be equal to 5 times 6 will give me 30 s squared plus 5 times 4 will give me 20x. Okay, then 2s cubed plus 2s squared plus 1 all to the exponent of 4. So this becomes my answer. 5, 6, 30s squared plus 5, 4, 20x. Then this all to the exponent of 4. After here, then I can end my answer at this particular point. Alright. Then C. Y is equal to square root of 3s squared minus 1. So so first of all, before you differentiate, write this as what? 3s squared minus 1 all to the exponent of 1 over 2. You know square root is exponent of 1 over 2. Then we can say that your dy on the x is equal to, then you take this one, okay, and bring it here. Then you multiply here, you subtract 1. Okay, then you have 3s squared minus 1 all to the exponent of what? So 1 over 2 minus 1 will give me what? Minus 1 over 2. Then times, okay, after that you differentiate whatever is in what? Is in the bracket, the binomial. So 2 times 3 will give me what? 6. Then x, then I subtract 1 from it, so it becomes 6x. Is that okay? Then finally, or you can continue like this. Half times 6 will give us what? So 3x, okay. 1 over 2 times 6x will give us 3x. So that is 3x. Then 3s squared minus 1 exponent minus 1 over 2. So I can write my answer finally as dy on the x to be equal to what? 3x. All the since this is exponent of negative, become 3s squared minus 1 all to the exponent of 1 over 2 positive. If you also like, you can say 3s all divided by square root of 3s squared minus 1, and this becomes your answer. Okay, we come to the d. Y to be equal to 2 over square root of 3 minus 2x. Okay, so what you do is to what? Bring this one as what? As a numerator. Okay, it's a denominator, so y will be equal to, so we know that the square root is the same as exponent 1 over 2. So when it goes up as a numerator, it becomes what? 3 minus 2s exponent negative 1 over 2. Okay, since we have this is a constant and it's multiplying here. Alright, so we are going to take the negative 1 over 2 and multiply by here. So negative 1 over 2. So it will be like 2 times minus 1 over 2. So 2 will cancel 2. Then we get what? Minus negative 1. Okay, so this is minus. Then 3 minus 2x. Okay. Then what will happen? We subtract 1 from here. So minus 1 over 2 minus 1. And that will give us what? Minus 3 on 2. Alright. Times whatever is in what? In the bracket here. Okay, so when you differentiate, you get negative 2. Negative 2. Alright. So if it happens like that, my dy on the x becomes what? Negative 2 times negative, here is 1. Negative 1 what? Positive. So I have 2 into bracket 3 minus 2x all to the exponent of negative 3 on 2. So my dy on my dx can be equal to a 2 divided by, alright, 3 minus 2x all to the exponent of 3 on 2. And if I want to write as a root, then I can write it as what? 2 divided by, so the denominator is square, so square root, but the denominator is 2. 3 minus 2x all to the exponent of the 3, which is the denominator. Okay. So this becomes what? Our answer. 2 divided by square root of 3 minus 2x all to the exponent of 3. So that is the D. I believe this is understood. Okay. So I think we can continue. Okay, so let's look at the E. Y is equal to s plus 2 all squared and then s squared plus 5. Okay, so here what we can do, okay, see that s plus 2 all squared, we can apply the chain rule here, but this is multiplying this. So after we differentiate applying the chain rule, we have to apply the product rule for all this, because the one function here is multiply another function, so the product rule. Okay, so the product rule is a differentiate this and then multiply by this plus differentiate this and multiply by this. So that is what we are going to do right now. Okay, So let me bring it here. So our dy on the x can be equal to, let's differentiate the first one. So if I'm applying the chain rule, 2 will come here, multiply. So 2 will multiply what? X plus 2. Okay, then we subtract 1 from here. So to be 1 times the differentiating of what is in the bracket here, which is what? Which will be 1. Because x will give us 1. Okay. Then after you have differentiated this, okay, you say that you have to multiply by this. So I have differentiated this and I'm going to multiply by s squared. Okay, so I'll multiply by s squared plus 5. Okay, then plus I'll differentiate this and I also multiply by this. So when I differentiate this, what do I get? I'll get 2x. Then I multiply by x plus 2 all squared. This also in another bracket. Alright. So I believe that we get this. So the differentiating of this is product rule. Differentiate this, multiply by this, plus differentiate this, multiply by this. So let's open up. So dy on the x will be equal to what? So we have 2 times x can give us what? 2x. 2 times 2 can give us 4. Okay, realize here is 1. Multiplying by s squared plus 5. Okay, so this is what we have here. Plus, here will be 2x multiplying what? X plus 2 all squared. We can maintain it like this. Okay, with this one, let's do expansions and see what we get. Okay, with 2s times 2s will give us 2s cubed. 2s times 5 will give us what? 10x. 4 times x will give me what? 4s squared. 4 times 5 will give me what? 20. Plus 2x. Here too, if you like, let's expand. Okay, so that let's see what we get. S squared. S times 3 times 2, 4x. 2 squared, 4. So that at the end of the day, we can have our dy over the x to be equal to 2s cubed, okay, plus, let me arrange the 4s squared plus 10x plus 20. So let me also expand this, okay, plus 2s cubed plus 2s times this will give me what? 8s squared plus 2s times this will give me what? 8x. Okay, let's see if we can write we have something that we can item that we can add and write our final answer. So 2s cubed plus 2s cubed will give us a 4s cubed and then 4s squared. So 2s cubed plus 2s cubed, 4s squared plus 8s squared. Okay, 4 plus 8 will give us 12, so plus 12s squared. Then we have 10x plus 8s. That will give us what? 18x. Then we have plus 20. So this becomes our final answer. 4s cubed plus 12x squared plus 18s plus 20. Alright. The last one, f y is equal to x over x squared plus 4 all squared. Okay, so to solve this, then let's take the denominator to be a numerator. Let's take it up. So y will be equal to x multiplying x squared plus 4 exponent negative 2. Okay, so here we have x and then we have x squared plus 4 exponent negative 2. So here we are going to apply the product rule and then the chain rule at the same time, because we have x here and the x is multiplying what do we call x squared plus 4 exponent negative 2. Okay, this. Okay, so here my dy on the x I'm going to apply the product rule. Differentiate this and maintain this. Differentiate this and maintain this. Okay. So when I differentiate this, I'll get 1. Okay, 1. Then I maintain this with s squared plus 4 exponent negative 2. Okay, plus. Then I also differentiate whatever I have here, and I'll maintain this. So I'm going to differentiate applying the chain rule. So only this part, negative 2 will multiply by what? S squared plus 4 minus 1. So minus 3. Minus 2 minus 1. Then after I've done that, I'll multiply by the differentiating of what is in the bracket. So we have 2x, okay, exponent 1, and then this is the 0. So this is what I'm going to get after differentiating this. Then I'll multiply by the x. Remember, I'm going to multiply this, so all this. There's a multiplying the x. That is how it should be. So differentiate this, okay, and I have done that. Then I maintain this. Then after that, differentiate this, applying the chain rule. Negative 2 will multiply s squared plus 4 minus 1 times the differentiating of which is 2s. Then multiply by this. Then I've done that. So now my dy on the s is going to be what? This is 1. So I can write this as 1 over s squared plus 4 all squared plus, okay, so negative 2s will multiply, so it will be minus 2s will multiply x to give me 2s squared, okay, times negative 2. So minus what? Minus 4 s squared, okay, then s squared plus 4 exponent negative 3. So negative 2 times 2 will give me negative 4x. Negative times negative 4s times x, okay, and then that will give me negative 4s squared. So this will now be equal to dy on the x to be equal to what? 1 over s squared plus 4 all squared minus 4s squared all over s squared plus 4 all exponent 3. So this negative will come down to the exponent of positive 3. So this is how our answer is going to be. Okay, so looking at where we reached, okay, we had 1 over s squared plus 4 all squared minus 4 s squared over s squared plus 4. If you like, you can also decide to write as a single fraction by finding a common denominator, okay, the LCM. So we have s squared plus 4 all squared, s squared plus 4 all cubed. So this is a factor of this. So we can write this as what? Dy on the x to be equal to, the LCM will be what? S squared plus 4 all cubed. Then s squared plus 4 all squared, this is cubed, so it will go here s squared plus 4, okay. So it will take 2 remaining 1 and then multiply by the 1, so that it will be s squared plus 4, okay. So this is square and this is cube, so it will go in remaining s squared plus 4 minus s squared plus 4 all cube will go here 1, multiply by 4s squared to be 4s squared, so that my dy on the x can be equal to what? 4 s squared minus 4s squared is minus 3s squared all over s squared plus 4 all cubed. So this can be my answer. Alright, so our answer can be 4 minus 3s squared all over s squared plus 4 all cubed. S squared plus 4 all cubed. Okay, I know this is not anything difficult and you have understood. I will see you again in my next lesson. Bye bye.